We are recording.
Thank
You
you.
have the floor, Axis.
Thank you, Beatrice. So we are here today to basically have a lecture today on coding for data science, which is as part of Education for Technology Literacy and Inclusion, Day 2, Session 1. And as part of the seminar for today, we'll be starting with understanding how the three key terms, data science, machine learning, and artificial intelligence are used in a these are terms which are used in different ways, but there are many commonalities between them, and we will try to look at these commonalities as part of today's lecture. And I'm just sharing my screen. Mm, yes. Is the screen visible?
Yes.
Yes. So,
Yeah.
as the slide suggests, so basically today in the first session, we'll talk about the methods of data science with reference to artificial intelligence and machine learning and data science. So these are three terms which are often used in a while we are replacing these terms with different meanings. So a lot of these terms are sometimes they replace each other's meaning because there are certain overlaps in these terms as well. So as you can see in the figure, artificial intelligence is the larger domain under which we have something called as machine learning. While we are discussing machine learning here, some of you would have also heard about the term deep learning or neural learning. So these are also terms which are used in the field of AI. But again, all of these terms, they have different meanings to it. While learning is the common term that is there across all these, but again it differs. So for example, as you can see in the Venn diagram, you can see that how artificial intelligence includes much more than what machine learning is. Machine learning is about how we teach machines to learn in such a way that they're able to use the data, and based on that data they're able to predict patterns. For example, these are some sort of terms which are there: support vector machines, decision trees. Like decision trees is that such that if there are, like, imagine decision tree as a tree which has different leaves and branches, and every branch can take to a different decision based on the data set that is being provided to the decision tree. Similarly, as you can see, there are commonalities of data science with machine learning as well. So data science is, as you can also, so data science is primarily used for gathering actionable insights for a particular domain. And when we are talking about data science, it has a lot to sort of derive from the larger domain of computer science. But data science alone is not really very helpful unless we're able to use it in a particular domain. For example, that domain could be climate change, or business, or related to sanitation, poverty, nutrition, health, any domain. But if we don't have, like yesterday we worked on a data set for climate, and we were able to we were able to look at the correlation between GDP per capita and the access to electricity in the particular countries that we were looking at. So that is how data science helps us to look at a particular data and learn from that data what is that data speaking. And it can then also be looked at through a visualization, as you can also see. So visualization helps us to look at data in a much more easier manner, in a way that our eyes are able to decode it faster as compared to just raw data of thousands and thousands of Excel sheets with data points, and we're not able to make out of what it is telling. So ML basically is about learning by example. When the term example here is basically data points term, like they work as an example for the machine to learn from. Moving on. So these are some sort of references of how these fields have sort of emerged over the past years. So the larger question, some of you might have heard of the Turing test. So Alan Turing is a renowned scientist who worked on the Turing test, and the whole idea was about if machines can think, if we can give data to machines and they can think. I'll give a very kind of contemporary example of it. So most of us would have heard of ChatGPT here. So how does the whole model of ChatGPT works? ChatGPT has a lot of data already fit in it, and I can maybe by the end of the slides I'll also show you. If we ask ChatGPT about a contemporary question, for example, if I ask ChatGPT, how many Security Council resolutions have been passed by the Security Council on ecological degradation? ChatGPT will answer me something like, as of XYZ date, XYZ year. Again, it depends on the model till which the ChatGPT data has been updated. So it just has data up to that particular year and month, not beyond that. So that is how ChatGPT has learned as a machine that this is the data set it has, and based on the questions that we ask, it will reply back to us and answer to us what we want, what we are asking ChatGPT. That is how a machine is being taught how the data it has, and how that data can be used to answer common questions. And so ChatGPT as full form, it's a general purpose technology. So it's used in a general purpose, but there are multiple ways in which the versions of it enhances and it sort of builds up. So as you can see, AI is the science and engineering of making intelligent machines, especially intelligent computer programs, and ChatGPT being one of them. And there are many on the internet. There are many computer programs that are being built. A lot of students use tools for like a machine is taught to how to paraphrase, or a machine is taught how to summarize a particular text, or any sort of way that we program a machine. So for example, yesterday we gave instructions to Python that if anybody is in the age group of 0 to 18, it's a minor, and 18 to 65 is an adult, but 65 above, we did not give any instructions. And ChatGPT, or sorry, Python does not know that human average age of humans can be, it's generally it can range from 0 to anywhere close to 100 or 120, 150. But even if I give a number to billions to ChatGPT, it will tell to me that it's a senior citizen. Again, that's how, again, depends on the way we have trained the model that we are using as part of the data set that is being provided, or the command that is being provided. And in case anybody has doubt in between, please feel free to unmute yourself and tell me if there's any doubt here. So yes, so as I was telling about artificial intelligence, moving on to machine learning. So machine learning is primarily making machines learn through data, and that data makes them make predictions or create models. So during COVID-19, there were a lot of models, like a lot of predictions being coming out in the news, that XYZ scientist or XYZ professor is saying that the third wave or any wave of COVID, it will suppress, or it was also about working towards a curve. The curve should get down, should get steepened up. So that was based on the previous data that the scientist or whoever was working on that data set. That data set was used to predict how COVID would sort of grow, or how the whole entire spread of COVID will happen. And I'm sure there are much more complex models to it. And I mean, some data sets are available on the internet for COVID as well to look at it. So those are the data sets of the past which are being used by scientists to predict COVID, how it will go ahead. And there were a lot of predictions out for that. Moving on, data science. So data science is primarily something which focuses on the statistics part of it, and using statistics and analytics to basically create actionable insights which are available from a particular data set. I'll come forward to some examples of that as well in further slides. Moving on, so these are, again, like I was explaining, AI, ML, and data science. So perspectives of it differ. Different scientists look at it in a different manner, but again, there are a lot of commonalities between these three terms: data science, artificial intelligence, and machine learning. So, I mean, so these commonalities are there, and again, it would depend from domain to domain, which domain are we looking at, and as per that domain, we can discover deeper insights into it. And this is also something that even I sometimes feel that there's a huge sort of overlap between these. So none of these diagrams that I'm showing here may be correct, but these are the diagrams that are generally used to refer to data science because it's a field which is still under vast modifications. There's a huge amount of research that is happening, ChatGPT being one of the popular ones, but otherwise as well, at a lot of institutes, a lot of research is happening on AI, ML, data science. Moving on, so these are some of the examples of how these tools are used. So for example, if I break down intelligence, so in terms of intelligence, it can be something to I've tried to break it down in the simplest manner possible through one of the papers that I found. So it's like intelligence is any kind of a smart task. That smart task could be planning, could be decision making, could be making inferences, or learning through problem solving. And all of this helps us to train. These are tools that are used to train our models, and so this reduces the human task of doing things which are repetitive. So again, this can also be done through text, speech, audio, image. Maybe I'll give one example. So these days, if we notice on Zoom calls or even on YouTube also, if we open, YouTube has the option where you can switch on or switch off the annotations. So how YouTube is trained is such that YouTube is given, it has been trained on a huge data set where whichever word I'm speaking in English or any language, it automatically gives me the subtitles. And those subtitles are based on the audio of the video file which has been played. And that is primarily based on the data set that YouTube has been trained on. So this field of particular this complete technology that I'm mentioning, I'm not covering that, but it is commonly known as natural language processing. I can type it in the chat as well for everybody. Okay, I'm not able to open the chat while I'm sharing, but it's called as natural language processing. So natural language is being processed, and that is how subtitles of that particular video is being generated. That's how the model is trained, and it automatically creates it. So when it is created, there are errors in that as well, but at the same time, it has a good enough accuracy for somebody who is looking at a YouTube video but does not understand the language, but still can refer to the subtitles and learn from it. Moving on, learning. So learning can largely be categorized in three key areas. One is supervised learning. So in supervised learning, we give a data set which has particular classification, or there is a particular pattern to the data set, and the data set has a particular sort of objective that we are looking at. So it's more like it's directive research, directive data science, which is to move towards a particular goal that we want to achieve through the data set that we are training the machine on. So for example, the language data set I mentioned, it is, we want the machine to understand the word apple as apple or class as class, but we don't want the machine to make mistakes in that, because there are certain meanings attached to these words, and it's important for the machine to understand it for the benefit of the users who will use that particular machine for their own work. Similarly, there's also we also have a lot of time series analysis work. So time series analysis again is like, yesterday I was showing a data set from the last 40 years of rainfall for a particular city. So something similar to that is a time series data set, which shows what is the time from which a particular event has happened. Like for example, COVID cases that are coming up. So over a particular amount of time, how the cases are coming up. So even though that's a time series, but it's somewhere unsupervised as well, because it may not necessarily be something which may have any control of a human, because something which is difficult to control. Moving on to unsupervised. So unsupervised is where we are not basically controlling the data set that we are using. And so this can also be used for anomaly detection. So this is something which is also commonly used for credit card fraud detection, because as common humans, we don't know who will commit a fraud when somebody is taking a credit through a bank or any non-banking financial institution. So these models are used by companies to basically understand their customers. Like in India, what happens is we receive a lot of phone calls or text from banks for loans or for availing their financial services, because they have a data set where they attempt to make predictions, and that is how those predictions there are being used for them to make the most of the data set that they have. And like a lot of us would have heard this quotation that data is the new oil. So that oil is then being, it's like used as a way to generate inferences of it, and those inferences are used to sell their products. Moving on, so something also called as reinforcement learning. Reinforcement learning is such that we are basically, the data set is free, but at the same time we want to derive a particular, we want to test our data. If that data is like, we have a particular belief and we want to test that belief, which will be used through, we use reinforcement learning models which help us to verify if what we believe is true or not, and we try to reinforce them through the data set we have and through the models that we apply to that data set. Moving on, so data science is, it's more like a process. We have the data and we basically work on that data through different tools of analysis, and based on those tools of analysis we try to generate visualizations and try to deploy that data and try to create inferences out of it. While a lot of times data science is also thought of that we get a data set and we directly work on it, a lot of times we also need to prepare that data. When I say prepare that data, I mean basically cleaning of the data. So I may have a data set which has multiple variables, but I may not have to use each and every variable for my analysis. I can just, if I have to draw a correlation, I can just pick 2 or 3 variables and try to look at them and try to draw correlations from them, instead of using all the 12. Like yesterday we had around 12 variables on climate change, but we were able to draw some inferences only from the 2 to 3 variables that we worked on, which was GDP per capita and access to electricity and the renewable energy sources that we discussed in yesterday's session. Moving on, so this is, so AI, ML, data science is there. It's used in so many different fields, and there are a lot of myths in this field. So I thought that it's important for me to also break down some myths for the benefit of the participants. So a lot of times people think that data science is all about coding. No, like yesterday we worked on the Excel platform. We did a very basic amount of code, which our code was not complex. It was simple, but the machine itself, Excel itself, was able to work on it and give us answers to the questions that we asked Excel. So data science is not entirely about coding. If you are not comfortable with coding and you're not able to get your hand on the code, because there is a syntax to be followed and there are many more minor rules that are there for Python, without which it will not run. So if you don't know that, that is also fine, but you should know what you want to find, what is the question that you have, and what do you intend to derive out of the data set or the code that you want to have. Next, so data scientists, so it's another myth that people think that data scientists and developers are more or less the same. So again, developers have a very different role and data scientists have a very different role. Developers have a role which is more similar to people who work behind the data scientist or behind the code, for machine to know, for Python to know that this means this, because Python is also a language that is invented by humans for so that other humans can use it. So they are different in the old ways. So in a way that, maybe if you look at it in a way that, so developers are the ones who are building the car, and data scientists are those who are driving that car to reach from point A to point B. So there are different roles, but both are very important. Moving on. So another myth is that data scientists don't need to know how to gather their own data. So because data scientists work on data sets and they need not collect the data, but unless they don't know how the data has been gathered or how data should be gathered, because they might also have to guide people so that they can gather their data. It's important for them to also know how do they gather the data, without which the analysis part then may not come out as the way a data scientist would plan it. Moving on. So another myth that if the predictions are accurate, it doesn't matter. So predictions can be accurate as per the data set. Like during the, I'm again and again giving the example of COVID because that's the one of the recent phenomena. So the data set can also lie. It's not that if the data set we are using may always be correct. So it should not be, the focus should not be on the predictions, but the process of those predictions. What are the key processes that has been followed even before the code, which where I'm referring to the data itself, how the data is gathered, is there any bias in the data, or what were the processes that were being followed, etc. So another myth that data science project start with data. So data can we can even use or work on metadata. So metadata in simpler terms is data of data. For example, so I was reading this in one of the papers that when we are using these normal cab aggregator applications to basically book our cabs or any of the online applications on our phone. So for example, Uber. So one of the so I need to go from point A to point B. The Uber application asks me that I want to go from point A to point B. In addition to that, there are a lot of other details that are being gathered. For example, the battery percentage that I have in my phone, the model of the phone which I'm using, the amount of time I'm using to basically book my cab. So all of these data tests, because a lot of times the price of the cab it differs. At least I have personally observed it on a lot of time, and there are various data sets that are being collected. And as part of one of the research, I was told that if I'm not sure how much of it is true, but I have personally experienced it. So the paper was telling me that if I have low battery on my phone and if it is at night time, if it's night and if it's my phone is on low battery, Uber may give me higher prices. The reason why is that Uber knows that my battery is low, and it also knows that it's night time. I may not get any other cab or any other vehicle to reach back. So this is something which can be used as a reason for any organization to charge a little a search pricing. So this is just one of the examples I read in one of the papers, but data of data is also used to basically work on data sets. So like we have heard of a lot of big companies who work on data sets, but again, it's a myth that only big companies use data science. From small to big, even if our data set is as small as 10, 20, 30, 40, it can give us great inferences. So it need not be something that only big data sets help us understand how to do work on data. So yeah, data science encompasses predictive modeling alone. No. So data sets can be of different kinds, and predicting is just basically we are looking at the future. But if we look at the data set like I was doing yesterday, it can also give us inferences of the data that we are using. So it need not just be predictions of the future. Another myth that people think that larger data equates to more accurate results and predictions. It may or may not be true, because larger data set, again, it also depends on the quality of data. Even if I have a larger data set, but the quality of data is not good, it may not give me accurate results. So while we work on data, it is also important that the data that is being used is having a good quality. Moving on, we'll show some of the criterias of good quality data as well. Another myth that it's just another name for computer science. No, again, we should not data science has a lot to learn from computer science domain, but it's not the same. Both are different fields, and we should not equate these two. A lot of people think that data, because data involves numbers, so one needs to be a mathematics wizard or somebody who is very good at maths to do data science. No, even if you are not so good at maths, anybody can learn data science and try to use data for their own particular purposes. Again, it depends on the domain that you are working in. It can be architecture, it can be cities, urban planning, or for example, like a lot of people are from architecture background or planning background. So maybe if you look at cities, how the distribution of cities are, for example, the amount of area that is being given to green parks or places with trees, and amount of area that is being given for roads, amount of area that is being given to residential buildings, amount of area that is being given to shopping complexes or institutional complexes, hospitals, schools, etc. So how these figures can also possibly tell us growth of particular cities, because no city can function with only one kind of infrastructure. There are different kinds of infrastructure required at a city to grow, because if people are there to live, people would need offices or schools or green areas or different kinds of places. So again, another just another example that came on the top of my head. Yeah, so this is I'm for this slide I'm ending with the first part of the presentation, just to give a basic understanding of what AI, ML, and data science it looks like, how there are some overlaps and commonalities between these, and how these three fields are used for different reasons. And I just thought of quoting the Nobel Prize winning economist Ronald Coase here, that if you torture data long enough, it will confess you anything. So yes, before we move on, in case there are questions, we can stop for a minute or two.
Yeah, Lakshish, I was just raising my hand.
Yes.
Yeah, can you hear me?
Yes, I can hear you.
Yeah, maybe I'm going to add another myth, not that you have missed, but I always, and as I'm going through yesterday's session and today's session, I always have one big question, no? That maybe is a question of someone who has already been around for some years, no? And maybe young people will not have this kind of problem, no? But sometimes I find that at the end of the day, we are human beings, no? And in order to manage the data, you need to mine the data, you need to get the data, no? And at the end of the day, you rely on specific people who have collected. It's very great to see this Excel sheet and with all these numbers, but someone has included that number in that Excel sheet, sometimes successfully and sometimes unsuccessfully because he was distracted, he didn't get it right. No, sometimes I find that that test with reality, I don't know how that test with reality is done. I'm going to give you two examples, no? And maybe you may not have a response to my question. One is just because we are both in India. For urban planners, we are a little bit tense in India because since 2011, the census has not been done. Okay, the census in India is done every 10 years. So in 2011 was the last census. And then in 2021, when it was meant to be the next census, the pandemic came, no, and then everything stopped. We are already in 2023. Census has not been done, and I don't know if it's been collected or not. And at some point, and we keep planning cities with a forecast of some data that we actually don't have. We are keeping, no, the reference of 2011. And even when I think 2011, is that for real? At the end of the day, this data is some little boy who goes household by household asking how many people live here. Do you have water access? Do you have electricity access in your house? No. How to do that reality test? All these machines, do they have mechanisms to show us that the forecast, the previsions are adjusted? Okay. And why I'm asking this question, because one of the things I find in the different generations, we are working in office, no? I am an architect, urban planner, who, when we finish our degree, there was not even computer. There were not even, so for ourselves to have AutoCAD was a revolution. And now to have all these softwares that are coming and are helping us a lot to create. But one of the things I always challenge to my younger generation is that when I say, how many, that is not 1 meter, because my eye knows what 1 meter or 4 inches is. Okay, let's talk it in English, sorry, in inches. I know how many 4 feet are. Okay, but my young architects don't know, don't have that text to reality. Okay, and how this technology is addressing this issue. This test of reality that says that we have measured how much is 1 meter, and I know physically how much 1 meter is. None of my architects, young architects, have taken that measurement. They have only worked through the computer. And I'm not against technology. I'm for technology. The only thing I want to know, that is technology worried about testing with the reality?
I hope I'm audible.
Yes.
Yes. So I completely am able to relate, because the census part that you mentioned for India, yes, that's been long pending. And because of that, we don't have data which is relevant. So again, census is trustable, but it's a 12-year-old census that right now, like when you're speaking for India's context. So again, the relevance of data is also important. So when a lot of us, when we work on our data, when we quote a data set or quote a study, so the relevance of it in terms of the contemporary times, that if it's very old, that's a problem. And its relevance with the technology. So as you mentioned that there are other people who go out and collect the data. So that is something which needs to be, like I was mentioning in the earlier slides as well, a data scientist should not just be knowing how to work on Excel or Python or advanced softwares, but one also needs to know the rules and principles that goes while we are collecting the data, and trying to use each and every way to avoid the biases and technologically collect the data such that we are able to draw inferences of it. So I mean, when I try to do it, one way that I try to do it is that even before I'm going to collect the data, I will design my questions or my options as per how it will give me the best inference. Maybe I can give a small example from yesterday. So yesterday when I asked those 3 questions, one of the question was about people telling me how proficient are they with Excel. So this is a dilemma that I had, and I'll share it with you. I thought that I'll give everybody a scale of 0 to 10 and 1 to 10, and they will tell me out of 1 to 10 where do they stand. But then I thought it's better that I give them a scale of 1 to 4, then 5 to 7, and then 8 to 10 in terms of the proficiency, which helped me understand where do they stand. So I think it's a lot about thinking of how people will be best able to answer or see themselves, and to avoid as much as bias as we can, or any other data quality issue. I hope I was able to answer your question. Hello.
Yeah. Thank you, Bashish. Thank you.
Thank you. So yes, so now moving on to the next section. So this is on the basic notions of machine learning. So some of these concepts are a little advanced, but I just want that while you are entering and starting off with machine learning and data science, it's important that you just people are aware of these concepts. So starting with how basically a model in a machine learning, like when we are working on machine learning, how it functions. So any model will have a particular data in it. That data, for example, is X. So that X, it would have, like, for example, there are various features to that data. Like if you notice the blue highlighted part, for example, it's volume of storage, height of a person, income of a person, etc. These are just some examples, and there can be more than one component in this as well. It could be a combination of these inputs, and the combination of these inputs can be used to determine to draw an inference out of it. For example, the height and build of a person. This can be used to determine a weight. So, sometimes when I think a lot of us would have also heard of the term BMI, body mass index. So, how body mass index function? It takes both our height and weight. Through that, there is a model that has been developed, and as per that model, it gives us that, okay, if you are normal, if you are overweight, if you are underweight, or so that is as per the model, and the model has been worked on with these two terms, and these two terms then tell us that if the person is normal, underweight, or overweight, etc. So that is how it is being trained. And so that was just an example that I gave. And output of it, so output can be basically, what does that data tell me? So this was just BMI was an example, that the data of height of a person and weight of a person is telling me if the person is having good nutrition or not, or if that person needs to work on his or her physical activities like going out to run or exercise or eat more or eat less, based on that. So that is the output that a basic simple model of a body mass index can be seen to understand how these two data points can only tell me how that person should go ahead and take further decisions. Similarly, there are a few examples that I mentioned on the slide. Moving on. So when we are working with data, please, in case there are doubts here, do let me know, because this can get a little complicated. So I'll try to go slow. So when we are working on data systems, we need to train the data on a particular model of data from the past. So we basically give our data to the model, and based on that model, we expect the model to do the task that we are doing. I'll be also showing an example for image processing data, how computers. So this is just another example. So has anybody experienced that when we click photographs on our camera, automatically the camera is able to identify a face, and it shows us that this person, there is a face here, and it sort of recognizes it and tries to focus it. The reason why it is able to do that, it is because the program of the camera or the mobile has been trained on that data set of faces thousands and millions of times, so that it knows how a human face looks like. Has anybody experienced this? Maybe you can unmute and tell me if you have experienced this.
Yes.
Yes. So that is how the camera is being trained to understand what basically a human face looks like. And that is based on the input. I'll also show you how these data sets work on. And moving on to what is testing data. So once a particular machine learning system is built, it needs to basically not, so like in the earlier point I mentioned, 80 to 90% is data is used for training, while the rest of the data is used for testing. So once the machine is being trained that this is how a human face looks like, it is being told, reiterated thousands and thousands of times. But after that, the rest of the 10 to 20% data set is used for testing it, testing that is it performing correct, is it working on the input that we've given. If I give a blurry image of a face to it, will it be able to recognize it? If I give half face image of a half face of a person, is it able to recognize it? That is how the data is being tested to evaluate the performance of it. And generally, like, there's a Google application called Google Photos, where if you go to the search option, it will automatically show you if you different faces, and if you click on one of the face, it will automatically show you photos of that particular person in your mobile or in your laptop, because the phone or the laptop has identified that face, and it knows that this is a different face of a different person. If you choose your face, it will automatically show you all the photos with your face in it. That's how the model has learned that this is a common face across. Any doubt here, in case, or we can move forward? All right, I think we can move forward. So yes, so while these data sets are being prepared, these are some of the performance metrics of it. So basically you can, as you can see, so the first metric is precision. Basically precision is the probability that an event that is classified by a model with one has been correctly classified. So it is about the way precision is correct. So as you can see in the on the right side, you can see that there is Tn, which is true negative, there is Tp, which is true positive, there is Fn, which is false negative, and Fp false positive. So a true positive, so these 0 and 1, this is used to understand. So I mean, I don't want to get into the details of it, but it's important for you to know because we are also uh, coming close to the end of the first half of this session. So, but it's important to know these things exist. So moving on, after precision, we have recall. Recall is basically, it's the fraction of correctly classified. So if the system is able to recall from the data it has, for example, I have 80 faces with me and I have 100 faces. Out of 80 I used to train my data. A rest of the 20 that I'm using to test, is the machine able to recall? And there is a particular formula that I've also shown in the screen, which is basically TP, as I'm mentioning, true positive upon true positive plus false negative, that is being used. These are the values that the machine learning model can generate for us. These formulas, you don't need to memorize it. The ML model can automatically apply it as well. And moving on, so the last metric, very important metric, is accuracy. So accuracy is basically how successful our predictions are with respect to the total number of records. So for example, I'm training my data on 80 images, and rest of the 20 I'm using for the machine to predict. Out of those 20, is it able to predict 10, 12, 13, 14, 15? That will help me determine the accuracy, and the formula for accuracy is there to basically determine the accuracy percentage. Generally speaking, for any ML model, it is said on the safer side, it's good to have an accuracy more than 80, 85%. 90, 95% is great, but 80, 85% is something which, as a model, it can begin with. Moving on. So again, these are some terms. I don't want to get into the details of it, but like I said, I just want the participants to know that these are very important terms in the world of machine learning and data science. So one of them, like I was talking yesterday also about, association analysis, which is how do we associate two different data sets and how those data sets are related to each other. Mm, Moving on, regression. So regression is basically, it's a simple prediction, and it is a more about a futuristic prediction of a particular data set, how the future of that particular data set would be like. So for example, for climate change, will the countries be able to increase their share for renewable resources? Are they generating more from renewable resources? What are the predictions? Like during COP21, COP25, countries, there are a lot of negotiations that they will reduce their carbon emissions by 50% as per the base year of 2015, 16, etc. So those are promised predictions or promises that are being made. So that is how basically on regression can be used to predict the future, and it's one of the most important analysis that is being used in the field of data science. Moving on, clustering is basically how we can see similarities between a data set and how they also inherit the properties of it. So I'll come to it in one of the further slides. Classification. So classification is primarily to see and understand if there is a particular label attached. So classification is just like I was telling you about faces. So a particular machine, if it is trained on particular key features of how a face looks, it classifies that particular image as a face. Similarly, uh, same goes with landscapes or sunsets or any particular. So this is how the machines are trained to understand that an image is a face or a sun or shapes or anything. That's how machines are learned, and that is they are being classified by machines and up in a particular way. Um, Similarly, time series, like we've discussed earlier, time series is basically we are trying to predict a future based on the data, the pattern that we have seen earlier. Moving on. So yeah, so as I was telling you about the way basically a particular model works on. So this is it's a classic example of iris flower data set. So machine learning, data science, and all of these are very recent terms, but this basically there have been scientist Ronald Fisher, biologist. He worked on how basically a multivariate data set is used for measurements in taxonomic problems. So what he did, he basically gathered data of the length and width in centimeters of sepals and petals of a particular flower. This is the iris flower. So this was used to understand if it is iris flower or if it is a different category of iris flower. For example, the first image, it shows iris setosa. I hope my cursor is also visible so you can look, focus on that. And similarly, iris virginica, similarly, iris versicolor. So based on the length and width of the flower, that was being used to understand how the flower and which category of iris flower it is. So this was one image, that was one way that the whole idea began, and then classification of image was formed. And yes, I hope I'm able to connect with images, how a computer classifies image, and how earlier, before computers came and before machine learning came, how humans were able to classify based on length and width of a particular element of the flower, which is sepals and petals. Similarly, when machines are trained on faces, the eyes, the nose, the ears, the hair, the mouth, each and every these details are used, and being there the data is being the machine is being trained on that data to understand how a particular human looks like, or like it can be again there for anything. Like a lot of times, I'm giving example of faces, but a lot of times the satellite imagery that is being used, the data sets are trained to understand where fire is being there, fire is has been sort of, there's a, for example, if there's a fire forest and nobody knows about it, how satellite images can tell us about fire forest, or if there are any other important reasons why we like, so many ways in satellite imagery is used. So to identify patterns in the satellite images, and like for example, degradation of our lakes and ponds, in case a lake or a pond or a river water body is degrading, satellite images can be trained to understand if the particular water body is degrading, and that data set is being used to do it. So instead of regular monitoring of humans, machine can be given the data, and machine can tell us which rivers or which water bodies are getting better, or if there is any sort of degradation of the water body. So these are just few examples how machines are being taught. Yes, so moving on. So basically this is just a way to show how the data set so looks like. So as you can see on the right side, it's a basically it's a diagonal histogram where you can notice how, so the blue color, the green color, and the yellow color diagrams that you can see, those colors, so basically that is the labels of the length and width of those sepals and petals. As you can see, the top two layers, so this part, this is the sepal length, and as you can see the data set, so this part, the blue part, it's on the center right side of it. And while we see there's a huge cluster of blue dots here on the left side, and again here on the left side in the third diagram, and that's how we see that there's a high amount of blue on this side, which is representing the data which we are studying. Similarly, if we move on to the sepal width, we can notice that there's a lot of data, a lot of sort of length at the central level. That's why we see all the three um, iris setosa. So that is the label is of those three flowers: iris setosa, iris versicolor, and iris virginica. And the dots, they are being represented by the histogram. Again, petal length and petal width showing the same. So I mean, I hope it's not very confusing and participants are able to understand. If you have any doubt, you can feel free to ask me. And if there's anything that you're not able to understand out of this, after this I'll also show you, if you want to work on these data sets, how do we get these data sets? Because I mean, I'm talking about data sets a lot, but where to get this? Because collecting them is also, it takes a lot of time. But if any of the participants are interested, I can show how we can get these data sets as well. And by the way, the tool that is being used here, it's a cpon. So in Python, there are different libraries. So you can say library is basically a particular uh, set of commands and instructions which are used by Python, and Python understands it as different libraries, and every library has a particular function. So for example, here cbon is a library that is used for data visualization. As you can see on the right side, the diagram, it has each and every data set in a histogram, and then there is area under curve. So basically the area under curve is the one which is diagonally moving. Let me show from the cursor. So these are the area under curve, and we can see how the dots which are high at a particular region, they are being represented higher in the data set that we are studying. Yes. Moving on. So these are some of the data quality dimensions that are very important to understand. And in case anybody has doubts on these, I've given references to all of the slides that I'm using. So all of them, you can go to those references and also read more about it. I'll share the slides. So yes, so these are some of the data quality dimensions: accuracy, completeness of the data, consistency of the data, timeliness of the data, uniqueness of the data, and validity of the data. So these are also very important, without which, if the data set does not maintain these data quality parameters, it is very difficult to claim any of the inferences that we gather from the data that we use. This is again, so I thought of having a bigger diagram for the iris dataset. And yes, so just wanted to quote, like, this is just a short anecdote. So basically in the 90s, a retail store in the US had to basically sell, had to basically bundle items for their customers. And a product association study was carried out, and based on that, it was found that there's a high correlation between baby diapers sales and beer for sales, and the tastes that were being found. So this is something which was very, it's a, again, I've given a disclaimer to that as well. And this was something which was observed through the data set. I don't want to get into the details of it. I'll share the details of it. You can read the paper as well and understand it. Another study is this one. So again in the 90s. So this is something which some of you may have heard also, that so one common way in which data is being gathered is our queries. So what do we search on Google? So if I search for example, it was observed in this case was that there were a lot of queries on Google which were related to symptoms for malaria. For example, if anybody is unwell, one would Google and try to figure out that what is the disease, or what is it that one person is going through. And based on that data, it was Google predicted that there is a potential outbreak. And similarly, there have been work which has been done which shows that disease outbreaks can also be predicted through Google, and it can be used to understand. So this is just primarily based on the query search, but again, like I was telling about GPS as well. So GPS can also predict earthquakes. But these are deep studies I can share. I mean, I'll share the slide, so that will have details of the links of it as well. And yes, I think that is it. That should be the last slide. Yeah, this is where I end for the first day 2, session 1 for Education for Technology Literacy and Inclusion program. And in case there are any doubts, we can discuss, or otherwise we can have a break and get back after the break.
Thank you, Rakshish. I think that's great. No, we can have a break now and continue after 10-15 minutes. Beatrice?
Yes, this is great. Excellent explanation. And we got into the topic within an hour, which is lovely. So congratulations for this. Great job.
Thank you.
Thank you.
Okay, see you then in 10-15 minutes. Oh, sorry, 10-15 minutes, okay? Maybe 10 minutes, Beatrice?
10 minutes is okay.
Okay, thank you.
Thank you. Bye-bye.